Hey guys, happy Thursday. Of course, I told you guys I will not be here today. I'm out in meetings all day. So we're still going to talk about skill factors today, but today you're actually going to be performing the dilation. So remember from yesterday, I was giving you guys the two pictures and you had to find the skill factor. Well, now I'm going to give you the pre-image. You're going to apply the skill factor and then get your actual image. All right, but before that, let's jump into this warm-up real quick. So again, set up your notes. You guys know the deal. Let's jump into this here. So it says if the new image is dilated by a scale factor of 4, then what would be the new length of A prime and B prime? So again, this is a pre-image here. I want to figure out what the actual image is on specifically what the length from A prime to B prime is going to be. So basically what happens, let's take a look at our scale factor. Scale factor is 4. So again, is that going to be an enlargement or a reduction? Well, because it's greater than 1, it's going to be an enlargement. So again, you should be drawing a bigger triangle. Still try to keep it as close as possible, right? The angles should still be the same. Okay. It's just that our size is increasing here because of the scale factor. Now, from A, this is no longer A, this is going to be A prime. Don't forget, once we apply transformation, we start using the primes here. So this is now C prime, and this is now B prime. Well, if it's a scale factor of 4, guess what's going to happen? Well, I'm worried about A to B, so I'm worried about this length from here to this length from here. It's enlarged by a scale factor of 4. So what does that mean? It means you're going to take 8 and you're going to multiply it by 4. Well, what's 8 times 4? That is going to be 32. So there you have it. That is the new length from A prime to B. Oops, I forgot the prime there. To B prime, that is a length of 32. And again, I could go through and I can find the length from B to C. All I have to do is apply the scale factor of 4. That's going to be 36. And if I wanted from A to C prime, multiply by 4, that is a increase all the way up to 24. Okay, so again, that's the basic idea behind a scale factor. Now, of course, we're going to go onto a coordinate plane. What does it actually look like on a coordinate plane, not just figures like this? I trust in you guys that you can multiply by 4 or multiply by 2 and things like that. So, copy down this title, performing dilations. How to perform dilations using a scale factor. All right, so if I'm going too quick, make sure you pause, rewind. You guys know the deal. Okay, so again, by the end of today, you should be able to perform an actual dilation, whether that's expanding it or shrinking it. So again, don't forget, in a dilation, it keeps the figure the same. So it's not like you start off with the square and you end up with the triangle. No. You just end up with a bigger square or a smaller square, depending on what way you're going. Again, all the angles stay the same, and you still have the relationship, right? Like this bottom of the triangle here is related to this bottom of this triangle. It's just it got increased or decreased depending on how you guys look at it. So let's actually jump into example 1 here. So again, take a second, copy that little cube in there. It says perform a dilation with a scale factor of 3. This is kind of like our warm-up again, right? This one's not too bad, but I don't give you the actual numbers. You actually have to figure that out yourself. Well, I know that this little square here measures a distance of 1, 2 at the top, and then 2 going also down below. So here's the idea, right? If I need to apply a scale factor of 3, first of all, because the scale factor is 3, I know this is going to be an enlargement. All I have to do is multiply by 3, and I get 6. So that new length right here on the top is going to be 6. If I multiply the bottom by 3, I'm also going to get 6. So this no longer is a 2 by 2 square. It actually turns into a, hopefully I can get this right. So we have 1, 2, 3, 1, 2, 3, 4. Oh, I messed up. 1, 2, 3, 4, 5. This is very difficult on this. 6, and I'm gonna go down this way. 1, 2, 3, 4, 5, and I'm gonna add one extra one. I messed this up. This is terrible. This is hard to do on a computer. So again, I went from a 2 by 2. When I applied the scale factor of 3, I now have a distance of 1, 2, 3, 4, 5, 6. And I have a distance of 1, 2, 3, 4, 5, 6. And there we have it. That's how we apply scale factors. All right. And again, that's a basic introduction. Here's kind of your tougher type of example. So let's jump into it. So graph that into, you guys, to graph the square A, B, C, D. All right, so take a second, pause it right here, and we're going to perform the following dilations. This is really the expectation for today. All right, so once you guys have it, here we go. It says perform the dilation with the scale, with the following scale factors from B. Now this is the key part, because this is kind of your anchor. Scale factor from B. What that means is everything is going to be in relationship to this point right here on our square. So I'm either going to shrink it or expand it, using as B as kind of like your center, that's your anchor. So everything is based off of that point. Now let's start off with the first one. Okay, it says perform dilation by a factor of 2. Well, I know that is an enlargement. Okay, it's greater than 1. So let's do that same thing. But here's the way that it's going to work. If you notice, this was a 1, 2, 3, 4. That was a distance of 4 here. Okay, and going down, it's a distance of 1, 2, 3. It's also 4. Okay, so when I apply the scale factor of 2, it's all in a relationship. It's all going to stay still anchored to that B. So let me multiply by 2 here. And of course, we get, this is a total of 8. And I multiply by 2 here. And I also get a total of 8. But and again, I mean, how far 8 do I go? Does that mean I just create an 8 by 8? Put that guy anywhere? No. Again, go back to, it's anchored at B. It's from B. I have to perform that dilation. So even here at B, I know that this went from a 4 multiplied by scale factor 2, give me 8. So I have to go now distance of 1, 2, 3, 4, 5, 6, 7, 8. That is now going to be our new C prime. And again, notice that B is going to be my anchor point. Everything's dependent on that B. So same thing, this 4 grew to be 8. So it's going to go 1, 2, 3, 4, 5, 6, 7, 8. And that's going to be now my new A prime. Well, how do I get D prime? I mean, I can just kind of complete the figure here. If I can do this correctly, go down and go cross complete your square. This is now going to be my D prime. And notice if it's square, right? If it was a 4 by 4, this is now an 8 by, and this also measures 8 down here by 8 over here. And there we have it. Now the secret behind this, again, what's the important piece? From where point? This was all dependent on B, which actually turns into now also B prime. And there we have it. We have an enlargement of a scale factor of 2. Okay, so reset this problem here. Let me see if I can erase everything. Okay, now let's try this exact same thing, but let's do it from, here we go, from point B. And let's do it by a scale factor of half. So again, because it's half, I know that's not going to be an enlargement. It's actually going to be a shrink, or what we call a reduction. Again, B is still going to be my anchor point. It's still a 4 by 4. Okay, but now I have to multiply by a scale factor of 1/2. So when I multiply 4 times 1/2, how the heck do I do that? Remember, this is 4 over 1. Multiply across your numerator, across your denominator. That's 4 times 1, which is 4. 1 times 2 is 2. That is now 2. So when I multiplied this guy by 1/2, I ended up with a distance of 2. Same thing's going to happen over here. If I multiply by 1/2, I end up with a distance of 2. I'll write it out actually here. So because it's a reduction, it makes sense, right? If I'm still anchored at B, now it's going to be only a distance. Oops, see if I can make this in a different color that stands out. Actually, we'll stick with blue. This is no longer going to be a distance of 1, 2, 3, 4. It's going to be a distance of 1 and then 2. You see how bold I can make it here? Same thing. If I go down, it's no longer a distance of 4. It's a distance of 1, 2. I'm shrinking it. I'm reducing it to from a 4 by 4 to a 2 by 2. And again, here's the thing. It's still anchored. It's still from the point B. And again, make sure you guys label your points. This is the new C prime. This is the new D prime on the inside. This is the new A prime down below. And this again turned into B prime since we applied a transformation. And again, it makes sense, right? You went from a 4 by 4 to a 2 by 2. You shrunk it by a scale factor of half. Okay, let's try it one more time. Or actually, we won't do it for this one, but by a factor of 3 and still from point B, all you're really going to do, again, you're still stuck at point B. This was 4. This was 4. We can actually do this pretty quickly. Well, if I multiply 4 by 3, that gives me 12. So I need to go a distance of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that's going to be the new C prime. I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and I actually don't have space. I actually run out of space here. But we get the idea. This would come off of my paper, my screen here, to be now a 12 by 12. And again, still anchored, big idea here, still anchored at B. Actually now turns into B prime, C prime, and then we can't see A prime or D prime. All right, so let's move on to this one. Actually, I want you guys to take a second, see if you guys can try this one out. And it's a little awkward, I know, it's a triangle, okay? But I want you guys to perform a dilation. So dilate the triangle using a scale factor of half. So first of all, reduction, enlargement. Yep, that's going to be a reduction. And U as your center. So you're going to use the letter U here as your center. So everything is going to get pulled based off of that point. So take a second, pause the video, try this problem out. All right, so let's go ahead and try this out. So from U to W, that was a distance of 1, 2, 3, 4. Okay. From U to V, that was a distance of 1, 2. And now I'm applying a scale factor of 1/2, so I know it's going to shrink. So when I do 2 times 1/2, that's really 2 over 2, or in other words, just 1. I know this guy right here has to reduce by 1. What about the 4? What's 4 times 1/2? That's 4 over 1. What's 4 times 1? That's 4. 1 times 2 is 2. 4 divided by 2 is 2. So there you go. My size shrunk from being a 2 by 4 to being a 1 by 2. So let's go ahead and get our new primes here. Let's see if I can do it in green here. So again, this distance still centered at U. The U is not moving. Distance of 2, when I applied the 1/2, it turns into a 1. So I go just a distance of 1, and that's the new V prime. Well, this was a distance of 4, but it got cut in half by the 1/2. So now it's a distance of just 2, and that's going to be my W prime. Now, why didn't I bother with this other side? Again, we don't want to count diagonally. That's not really how it works. That's not necessarily 1 right there, 2. No, it's not. We cannot count that way. But I can actually complete my triangle here, connect V prime to W prime, and actually this turns into U prime as well. And there we have it. That was a reduction. We see that it's shrinking down. All right, guys, try this last one. Pause the video right here. So again, dilate the triangle using a scale factor of 2. So I know that's an enlargement. And then G as the center point. So pause the video here, and I'll show you guys the answer in a second. All right, guys, so here I have a little bit of my work, right? I went ahead and I counted from G. Remember, that's our center. So I counted 1, 2, 3, 4 to F, and I did 4 times my scale factor, which is 2. I got 8. From G, I counted down 3, and again, multiplied by your scale factor, and I got 6. And then I went from H all the way to E. I counted 5, and I multiplied that by 2, and I got 10. Now, again, I'm not going to worry about this diagonal here. Hopefully, I have enough information to complete the enlargement. In this case, it's a dilation by 2, so it's going to get a lot bigger here. So, again, still centered at G. I'm going to cross 8 spaces now, so I'm actually doubling it here. So let's go 1. Whoa, what happened? 1, 2, 3, 4, 5, 6, 7, 8. That again, what used to be F is now F prime. I performed the dilation. Actually, before I forget, I should make this G prime. Okay, now let me get my new H prime. So it used to be a distance of 3, but I scaled it by 2, so now it becomes 6. So let me go down 1, 2, 3, 4, 5, 6. And again, that's no longer our H, it's now our H prime. And now from H prime all the way to E, well, that's a scale of 10. I don't even think I have enough space, but let's go for it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's pretend we actually did it up to there. And again, that would turn into no longer E, but E prime. And again, I can just connect from F to E prime. Here we go. Done. And again, we see that enlargement. All right, guys, here is your class activity. Pause it right here right away. I'm running out of time on my recorder here. Don't forget to get paper from my sub. And again, break it up into kind of 4 squares. That's really what you need. You have a part A, part B, part A, and a part B. Don't forget about the important pieces. W is your center. And then over here, A is your center. Have a great